Welcome to Applied Physics Laboratory. Now we have a black box experiment. Here, black has got nothing to do with black body radiation. Here, black indicates some unknown electrical components. Coming to the aim of the experiment, the aim is to identify and determine the values of passive electrical components present in the circuit. Passive electrical components are nothing but any component which store, dissipate, or transfer energy is nothing but passive electrical components. Coming to the operators, we need a functional generator as well as a circuit board. In this experiment, for each values of frequency, we have to note on what is a voltage gain. What is voltage gain? It is represented by AV. It is nothing but it is the ratio of output voltage to input voltage. In this experiment, for each values of frequency, we have to note on what is a voltage, output voltage, what is the input voltage, and we have to take the ratio. In order to avoid that, what I do, I'm going to set the input voltage to 1 volt, so that whatever the output voltage you get, that itself will become voltage gain. And we know that for a capacitor, voltage gain is directly proportional to frequency. For inductor, the voltage gain is inversely proportional to frequency, and for resistor, the voltage gain is independent of frequency. By using this theory, we are going to identify what is a type of unknown component present in the circuit. So this is the conduction. We have two instruments. One is the circuit board and the function generator. In the circuit board, we have three unknown components, that is Z1, Z2, and Z3. We are going to identify what is the type of component, and also we are going to calculate what is the value of Z1, Z2, and Z3. Coming to the function generator, here we have different knobs, that is frequency knob, pulse width, DC offset, and amplitude. We are not going to use pulse width and DC offset. We also have the ratio of power, that is 20 decibel and 40 decibel. We are not going to use that. We have range setter. This can be used to set the frequency range. Ensure that it should be kept to 0.8 kilohertz. And we have different waveforms. Since it is AC source, we are supposed to keep the waveform to sinusoidal. Initially, we have to set the input voltage to 1 volt. For that, connect the output source from the function generator to voltmeter directly. So once you connect this to voltmeter, you can use amplitude knob of function generator to set it to 1 volt. Use this amplitude knob and ensure that it should be kept to 1 volt. Once you are done with the input setting, turn off both the instruments and connect the output source from the function generator to input source of the circuit board. Then ZX should be connected to Z1, Z2, and Z3 after taking readings. So connect this ZX to Z1 initially, and from the input V0, the output should be connected to input of the voltmeter. Plus should be connected to plus, and minus should be connected to negative terminal of the voltmeter. Once you are done with this, turn on both the instruments and go to the frequency knob and ensure that it should be kept to 1 kilohertz. Now it is 0.8, adjust it to 1 kilohertz. And take the respective voltmeter reading, that is voltage gain 0.914 in this case. Once you are done with this, again go back to frequency knob, keep it to 2 kilohertz. Respective voltage gain should be noted down, and repeat this up to 10 kilohertz, the difference of 1 kilohertz. From 1, 2, 3, 4 up, you have to go up to 10 kilohertz. Once you are done with this, again turn off the instruments, connect Z1, should be connected to Z2 now. Once you are done with the connection of Z2, turn on the instruments, both the instruments, go back to the frequency knob, again bring it to 1 kilohertz, note down respective voltage gain, similarly keep it to 2 kilohertz, note down what is the voltage gain. You have to repeat up to 10 kilohertz, again connect it to Z3, repeat the same thing, frequency from 1 kilohertz to 10 kilohertz. Coming to the tabular column, here you have varied the frequency and we have noted down what is the respective voltage gain frequency from 1 kilohertz to 10 kilohertz, and you have noted down what is the voltage gain. So we know that just from the theory, suppose if the voltage gain is directly proportional to the frequency, that can be called it's a capacitor. Suppose if the voltage gain, you can see here 0.89, it is reduced to inductor. It is inversely proportional to frequency, that is inductor. Here 0.48 doesn't depend on the frequency, it is independent of frequency, that is a resistor. Coming to the calculation, you have to plot a graph of voltage gain versus the frequency in kilohertz, where the capacitor and inductor meet. From that point, draw a horizontal line that becomes AR, vertical line that becomes the free resonance frequency FR in kilohertz. So here you have to calculate four parameters. One is the impedance, inductor, capacitor, and you also have to calculate what is a resistor. So RL, it is given in the instrument itself, it is 1 kilohertz. AR, you get it from the graph. Let us assume the AR value is 0.67 and the FR value is 3.1 kilohertz. So by using this from the graph, you have to calculate all these parameters. Now inductor Z square minus RL square divided by omega. Omega will get it from here. 2 pi FR is the formula. 2 into 3.142 into 3.1 into 10 power 3, that is in kilohertz. You have to convert it to hertz. And capacitor also you can calculate. From the relation Z equal to R plus RL, you have to calculate what is R. Z impedance, you will get it from the calculation from here. And RL from the instrument, it is 1 kilohertz. Now you can calculate inductor, capacitor and resistor as well as impedance value. So Z1, Z2, Z3 are inductor, resistor, capacitor respectively. The result, inductor, capacitor, impedance and resistor, you calculated using the formula. Thank you.